To start off, the Epic India Dialogue series is a flagship series where we convene a group of specially curated experts who discuss and debate India's serious challenges at the crossroads of energy, environment, and climate change. Today, we are bringing the focus to how climate change is impacting the landscape of Indian cities. As cities expand and face untimely weather patterns, they often face rising sea levels and untimely and intense rainfall. And all of this leads to a almost disproportionate impact on vulnerable populations in megacities. Today, we have almost been like it's been 2, 3 days that we have all experienced and witnessed that what even 1 or 2 hours of intense rain does to even a modern and developed city. Everything comes to a standstill. And imagine something like that level of flooding in an informal settlement where there is not much of great drainage systems. So when a stagnant level reaches to a place like that, it often creates serious health hazards. It leads to hygiene issues and often in increased cases leads to mortality risks. Ashwin Rode, our director of scientific research at the Energy Policy Institute at University of Chicago, is working towards understanding exactly this problem. His recently authored paper that he's going to discuss today understands how rainfall and sea levels impact mortality risks in Indian cities. As I mentioned, Ashwin is associated with EPIC, and he's also a fellow at the Climate Impact Lab. A brief introduction about him. He received a PhD in economics from the University of California, Santa Barbara. His research focuses on the global economic impacts of climate change and has appeared in journals such as The Nature and the Quarterly Journal of Economics. Chairing the conversation today and joining us is Ms. Dr. Debolina Kundu. She's the Director for National Institute of Urban Affairs, a leading think tank under the Ministry of Housing and Urban Affairs, Government of India. She has over 20 years of professional experience in the field of development studies. She's also a doctoral fellow with the ICSSR and has a PhD from JNU on urban governance. Dr. Kundu is recognized for her work on building urban resilience and integrating climate and public health considerations into urban policy frameworks across India. So without further ado, I welcome all of you once again to this engaging and interactive discussions. I think we can all ask the questions that when we think of climate change, how do we think it's impacting our day-to-day lives and how it impacts at the nexus of health, urban development, and climate. So without further ado, I invite Ashwin Rode to please start with his presentation. Thank you.
I'd like to thank for organizing this and also Dr. Kun for participating in this event today. So I'm going to describe some ongoing work on the urban mortality consequences of rainfall and sea level rise. So to give some background, flooding affects more people globally than any other natural disaster. And while major flooding events such as those from tropical cyclones generate international attention, small-scale, frequently occurring localized events often go unnoticed. They're hard to detect, and as a result, their impacts go unaccounted for. And in particular, many urban areas in the global south routinely experience disruptive flooding, which has public health consequences. And this is also true in, varying degrees to the global north as well. So just to give you an idea, so this is happening in many cities around the world. For instance, Lagos, Nigeria, Jakarta, Indonesia, Manila, Philippines, and Mumbai, India. So it's a challenge to understand what are the public health consequences of these kind of events. Often in other research, satellite imagery is used to detect flood extent. However, satellites don't work so well in very densely built urban areas for this kind of purpose. Also, flood depth gauges and measuring accumulation of water is not readily available in many cities in developing countries. So we develop a different approach to get at this question in this paper. So we estimate the causal effects of daily localized rainfall shocks uh, on mortality in one of the world's largest cities, Mumbai, right here in India. So we bring together some novel data sources to do this. So first, we have daily person-level mortality records identified by residential address for every person who died in Mumbai between 2006 and 2015. This is extremely detailed vital statistics data that are going to power this analysis. We match that with hyperlocal sub-daily rainfall measurements. And then thirdly, we're also going to make use of the timing of rainfall with respect to tide height fluctuations. So high tide is known to impair drainage capacity and settings around the world, urban settings around the world. So rainfall during that high tide is going to be a greater flooding hazard, and we're going to examine the human consequences of that in this work also. So first, just some background on rainfall in Mumbai. We're in India. We're familiar with the seasonality of rainfall. Virtually all the rain comes in 4 months. But the additional feature we're going to use here is that rainfall on a given day tends to occur in these localized cloudbursts, which drop heavy rain on some parts of the city while leaving other parts dry. And meteorologists try to study this phenomenon of how rain is distributed across space in a day, but they seem to get very frustrated and they use terms like arbitrary and patternless and elude statistical prediction. So these are obviously very bad things from the standpoint of meteorological prediction, but it's actually very good for the econometrician. It's going to provide us with the kind of random variation that can identify a causal effect on health outcomes. So just to give you an idea of what this variation looks like on the ground, these are an example of 2 days during the 2007 monsoon season in Mumbai, and it's showing the spatial variation in rainfall across the city's 89 pin codes. And darker colors indicate heavier rainfall on that day. So we see on the 3rd of August, there was heavy rain in the southern and especially south central part of the city. However, on another day, June 30th, the northern areas got more of the rainfall. And all the days in our sample, which generally consists of the monsoon months over this roughly 10-year time period, there is this spatial variation in rainfall that we're going to use in the econometrics. So the rainfall data are going to come together with we're going to bring it together with the vital statistics data. So this is immensely detailed vital statistics data, individual mortality records with some basic information, and especially important, it has the address of the disease, residential address. We're going to use that address information in 2 ways. So first, we will locate each death to one of Mumbai's 89 PIN codes based on the address. And we also develop an algorithm to use the text of the address to classify it as either a slum or non-slum address. So we want to look at the unequal vulnerabilities of different subpopulations within Mumbai. This. So this data in itself is very interesting, even aside from the climate or environmental implications. I'll just give you an idea of what it looks like on a map. So we see, just looking at the descriptives of this data, tremendous baseline inequality. So if you plot the mean age of death by PIN code, we find that in areas that are known to have large slum concentrations like Dharavi, it's under 50 years. In affluent areas that are home to billionaires, like the Breach Candy neighborhood, that PIN code has a average age of death of 74 years. So this baseline inequality is going to also create unequal vulnerability to environmental and climate stressors. Okay, I'll just describe the econometric model in qualitative terms before going on to the results from that model. So the basic exercise here is to model a nonlinear response of weekly mortality to daily rainfall. So how does a day with, let's say, 150 millimeters of rainfall affect mortality in that week as well as in future weeks? So our model is going to account for impacts up to 5 weeks later. And importantly, the econometric methodology here is to flexibly control for all kinds of unobserved confounding determinants of mortality that might be correlated with rainfall. So we want to get at a causal effect. Hence, we need to control these confounding factors. So we use the latest methods to do that. So the things we control for include the effect of citywide shocks in each week of the sample. So this might include various determinants of mortality like terrorist attacks, large-scale pollution, environmental conditions, etc. We also are going to control for locality level trends in demographics, infrastructure, socioeconomics, politics, etc. And we're going to do this in a flexible way that does not require us to individually enumerate each of these control variables, but so non-parametrically. So this is for the econometricians, but this is the end result. So this model that we developed shows predictive skill in predicting pin code level weekly mortality. So this is just a scatter plot of predicted deaths to pin code by week against the observed deaths in that same pin code, same week. And we see that the predicted deaths are pretty well correlated with the observed deaths. This whole scatter plot is clustering along the 45-degree line. So that this model is showing predictive skill, which gives us some assurance about what we're going to get about the results of the effect of rainfall. Okay, so now I'll get into the core results here. So this is the rainfall response for the population as a whole. So this curve is showing the effect on mortality over 5 weeks of a single day with rainfall indicated on the horizontal axis. So a single day with 150 millimeters rainfall causes about a 2.2% increase in mortality relative to a dry day with no rainfall. And it is convex, it's non-linear, so it gets worse as you get higher rainfall. So a 300 millimeter day causes around 7.5% increase in mortality over those 5 weeks. And we find that there's actually not just a contemporaneous effect, but the effect persists over that whole 5-week period, suggesting that spread of diseases is a big factor here. So we don't have cause of death data. This is all causality, but this is very suggestive, the mechanism. Children under 5 are the worst affected age group. There's some evidence that women are worse affected than men, but this deserves more research. Slum residents are far more affected than non-slum residents. Okay, so we can go even further than what we showed thus far. We can actually look at hourly intensity of rainfall and the effects of hourly rainfall. So this is basically that same kind of nonlinear effect, but of a single hour with this amount of rainfall. So a single hour with 30 millimeters of rainfall causes a 0.5% increase in mortality. So this intense rainfall is really bad, we find. And we can also distinguish whether that hourly rainfall happened during high or low tide. This is the tidal variation for just an example week for illustration. And we can overlay the rainfall with that. And we can see that sometimes rain falls during high tide, sometimes during low tide. And we can differentiate the effect of hourly rainfall during those different tidal heights. And this is what we find. So this is the hourly rainfall for, on the left, the fifth percentile, so very low tide, 94 centimeters, all the way to 95th percentile, a very high tide of 416 centimeters. So we see a much greater effect. Even small amounts of hourly rainfall result in elevated mortality than that occurs during a high tide. So what does this all add up to? So we can calculate the excess mortality due to rainfall over and above sort of the predicted mortality over the whole year. And that amounts to around 8% of total monsoon season deaths and 17% of under 5 deaths during the monsoon season. And this is comparable to the mortality burden of cancer in Mumbai. Numerically, this comes to 2,500 deaths per year distributed across different subpopulations. And we find that the excess mortality from rainfall is borne virtually entirely by slum residents, so 88% by slum residents. So very unequal impacts. We can also extend this method a little further. So we know that rainfall has worse mortality impacts during a high tide. So what does that tell us about rising sea levels? So we can basically think of that to a first order approximation, not a detailed model. We can think of sea level rise as elevating all of these tidal heights. So this is the variation with no sea level rise. We can raise it by 30, 60, 90, and this would be the tidal variation under those sea level rises. And we can calculate how much would that excess mortality increase under those elevated sea levels. And we find approximately that a half-meter sea level rise would increase the rainfall-driven excess mortality by around 50% in the absence of adaptation and re-engineering measures to prevent this. Okay, so to conclude, yeah, there are a number of caveats to these results. It's likely that extend even more than 5 weeks. We don't quite understand all the mechanisms, but there's definitely a very large effect here on vulnerable populations. Some auxiliary evidence suggests that waterlogging is an important channel for all this, and that infectious diseases also are very important. They seem to respond to rainfall similarly to the mortality. And the impacts of sea level rise, again, underscore the need for adaptation and re-engineering to protect against these harms from escalating in the future. So yes, in conclusion, future work should really look at the potential benefits to various kind of urban investments, whether it is sanitation, improved housing, drainage, waste management. There are likely to be large benefits, especially to vulnerable populations, to these kind of investments, and we should really, this work should impel us to look further at that. And future climate change poses additional hazards, both in terms of projected intensification of monsoon rainfall and this new channel through which sea level rise can endanger human lives through compromised drainage and increased hazards. Okay, with that, we can move to the discussion and questions. Thank you.
I'd like to take this opportunity to thank the University of Chicago Center in Delhi for inviting me. Also, like to thank you, Dr. Rode, for this illuminating presentation. I think the order quantification of rainfall, tides, and urban mobility really gives us critical insights into both the mechanics and also the acuity dimensions of flood risk. I would like to briefly share three key takeaways before we dive into the pointed questions. First, hyperlocal data can reveal hidden health burdens in informal settlements. I think that's very important. Again, the compound hazards from cloudburst to tidal co-occurrence demand integrated adaptation strategies. And modeling future sea level scenarios is essential for informing long-term resilience planning. I think with those points in mind, I have tried to organize my questions into four thematic areas. First, the methodology, transferability, and future risk frameworks, followed by the data, health outcomes, and vulnerable populations, followed by our understanding on urban inequality planning and adaptation. And lastly, the economic instruments, policy evaluation, and risk financing. Now, going to the first vertical, what I understood from the presentation is that your study really tries to leverage on Mumbai's hyperlocal rainfall and tidal data, if I understood correctly. It's unique drainage infrastructure and slum geography. My question is, how would you transfer this methodology to other coastal metros like Kolkata or, for that matter, Chennai, with again different monsoon patterns? The topographics are different and also their sewerage systems. And what adaptations would be required to apply in inland cities, Delhi, Lucknow, or any other, that also face rewinding and also cloudburst, heat waves, and other natural climatic hazards.
Yes, thank you again for joining us. Yes, Mumbai definitely has some special features in this regard. It is built, large parts of it are built on reclaimed land that's really meant to be underwater, one could say. There are also natural drainage sources that have been compromised over time, like the mangroves surrounding the city. And yes, the hyperlocal data were available here, which made it ideal setting to study these things. However, I think a lot of the common themes here emerge for other cities as well. So the combination of rain tide patterns would be relevant to coastal cities like Chennai, Kolkata also. In fact, the hydrologists study this phenomenon. They have a name for it. It's called tidal jacking. But they study with respect to the physical flood hazard that it creates. And what, as social scientists, we would like to do is go the step towards what are the human impacts of that. And studying those in other Indian cities and global cities is definitely possible for the coastal cities. And as far as a more broad set of cities, including those along rivers, a similar approach could be used, but instead of tidal variation, we would want to take into account of things happening upstream. This might include precipitation upstream or glacial melt in the Himalayas or something like that. So yeah, we can definitely adapt the methodology to those settings as well, I feel, and we would like to do that in the future. And hyperlocal rainfall measurements are definitely useful, and rain gauges are relatively a key form of data measurement. And there has been increased spreading of Like, I think there is a network in Chennai also now. And many places in the world have this kind of, I mean, some places might have more spatial uniformity than others in how their daily precipitation falls, but some amount of variation is there in many cities, which we could use in the econometric method.
Thank you. I think we, for the other inland cities which are riverine, the methodology could be tweaked a bit. And for cities like Chennai, and many other 100 cities in the country, which were, which could access the smart cities fund. And through smart cities fund, special purpose vehicles were established. And also ICCCs, right? Integrated Command and Control Centers. I think those centers now with the, now that the smart cities mission has come to a closure, we could take help of those smart ICCCs and get the daily real-time data on various climatic events and also temperature. I think that go way to go ahead with regard to at least taking into account what are the various climatic hazards, how that those would impact us in future.
Yes, very much so. And besides that, these call centers are at the front lines trying to help with the solution, right? So understanding how to, those could be the most effective is also possible through leveraging that.
So coming to the next question, I think your analysis uses the historical occurrence of rainfall and tides. So my question is, how would you extend this framework to incorporate climate model projections of monsoon variability, extreme event frequency, and compound hazards like concurrent heat waves and flooding to inform long-term resilience?
Yes, what we learn from history, we have to then apply for the future, right? But the future is going to look different than the present in many ways, climatically as well as socioeconomically, right? So we tried to show like what will happen in the absence of adaptation if sea levels were to rise by their amounts projected by IPCC under different scenarios. We have not accounted for intensification of monsoon, which is widely thought to be what's going to happen under climate change. So as climate scientists, in some of our other work, we have leveraged some of the latest climate science advances on modeling like local daily extremes of temperature. So not just the annual average temperature, but how many days is Delhi going to have above 40 Celsius? That's the kind of specificity and granularity that climate models have now able to reach on temperature. And it's very important that we have that because of those non-linear effects of the extremes, right? And they have not yet, clouds and rainfall are just a harder problem to solve, as I understand from my climate scientist collaborators. So they're getting there, but have not yet reached that same level of daily extremes as with temperature. But as those advances occur, we would definitely feed them back into our research and into those projections.
Okay, so now going to the next proposal on data, health outcomes, and vulnerable population. We are all aware that most of our cities have vulnerable population. Slum, if not slums, like most of our cities. So given your that your analysis used all-cause mortality, a great achievement, I believe, amid data constraints which we are currently facing. How can we generate city-level exposure-specific mortality and morbidity data, linking particular hazards to health outcomes, and also use this evidence to strengthen national and subnational climate action plans, demonstrating both the health benefits and also the economic savings.
Yes, all cause mortality data is the best we could do. It has certain advantages. It also has certain disadvantages. So just for some background, cause of death is often hard to pin down in just four categories, right? So for instance, for heat or flood mortality, there's actually relatively little mortality that's recorded due to heat stroke or due to drowning from a flood. But these kind of shocks disrupt other things. They disrupt essential services. They create congestion in hospitals. They create income shocks, such that all these things have effects on mortality that whose cause is not limited to just heat stroke and drowning. So there's an advantage in looking at all-cause mortality, but at the same time, we would also like to understand the mechanisms uh, in better detail. So yeah, incorporating cause-specific things, cause-specific mortality data is definitely the way forward. And then also on the health savings, no, the economic savings if we improve on the health front, right? So we should also be looking not just at the extremes of people dying, but also morbidity, which is also likely to respond to heat or rainfall. And there could be significant productivity gains from avoiding this if we can avoid this morbidity, right?
That's very critical. It's not that person doesn't talk about the health habits, but also maybe he or she is pulled away from the economic activity
Yeah.
for a long duration and not being able to really contribute to the economy
Mhm.
because of some sort of mobility. Again, resulting from the extreme heat.
Yeah, it's one of those kind of hidden costs to the economy that's dispersed very widely, but not visible in a big way. Yeah.
So coming to the next question, I believe you used disaggregated mortality data by slum status and also by age groups. So how can we effectively incorporate various data sets like the which we generally use from the NSS, like the migrants, the share of migrants versus non-migrant population or the informal sector or the undocumented population really who have arrived to the city but who are not really seen in the city. And how would you incorporate them to in the analysis to create a more comprehensive risk profile? And how might we tailor the public health interventions to reach these often groups?
Yes. So our analysis was, I mean, the set of the population that it applied to are those who had in their address record for the mortality statistics, it had to be in Mumbai. So that was the population to which these results apply. But yeah, it's likely that those who are temporarily in the city, migrants, are definitely among the most vulnerable. We have some evidence in auxiliary analysis that among the slums, those that are recognized by the government are not as vulnerable as those that are not. So in way, it might be all over India. It's called notified and non-notified. Yeah. So the non-notified ones are especially vulnerable. So yeah, the things that improve well-being generally, like the services that would come with notification of the slums would also improve vulnerability or reduce vulnerability to these climate shocks.
Yeah. And the notified slums, or as far as my knowledge goes, they are being notified by the government to really improve their level of basic service.
Yeah.
Once the notification happens, these are supposed to be improved.
Yes.
And then once happens, then it again be implied. So we worked on a study sponsored by the HUDCO when I was in the National Institute of Urban Affairs. We looked at all the 7933 urban settlements across the country. And 7 out of them were 100% notified slums.
Mhm.
And in
Do you know which one?
there were small ones, I do not know, remember their names as of now because I've been studying for a few years back. But they were not big cities, they were small towns.
Yeah.
with a Population range of 5,000, 50,000. But the entire settlement was notified as a.
So nobody was excluded.
Nobody were, which I believe was a very good measure. So that the entire settlement, maybe not just now because it's already 10 years, has been developed into a proper
Mhm.
residential area. I think that that's important on the part of the government to recognize the vulnerability of those localities and bring up the.
Yes, absolutely. Yeah. And there are likely to be very large returns for doing that.
Right. So coming to again a related topic of urban inequality, where we plan and adapt from policy perspective. And also embed mortality risk into urban infrastructure and planning. So how can city planners integrate fine-grained mortality rainfall risk maps into zoning regulations, building codes, and slum upgrading programs? And what instruments and institutional arrangements such as inter-agency coordination between various departments like health, urban development, disaster management, your idea of how do you really like to make them operational? The
Mhm.
belief is currently not at that stage.
Yeah, I think the first step could be a better exchange of information among these departments. So, for instance, the drainage department is taking efforts to maintain drains or build capacity of drains. And if that can be tied to health outcomes, like we can save lives or reduce morbidity by improving drains, then that can provide a more robust basis for action, knowing that these things have these spillover effects and these include not just the effects through market value things, but also non-market effects like people's health.
I believe there's also needs to be some sort of synergy between various departments and ministries. Their sister organizations working in cities.
Mhm.
They need to collaborate.
Yeah,
All are working for a common cause, which is development.
yes,
So that development cannot be in silos. The data needs to be integrated and also the policy interventions.
yes, it has to be
So I feel
at all levels.
I think that policy integration into practice is
Yeah,
very important going ahead.
I'd like to just move to the slides and feel that it would shed light on this particular question, one thing here. So any projection to 2100 should be taken with a grain of salt, but these are mind-boggling numbers of people projected to live in some of these cities. And the densities here are just mind-boggling. So how can we, I mean, this is a challenge we face as kind of a backdrop trend of global South urbanizing. So how can we plan in such a way that we can protect people's lives from these extreme events?
The point I would like to make is from 20 or 0 to 2100. If you come in between 2030,
Yeah, 5 years now.
5 years from now, Delhi will be the most populated city in the world.
Mm-hmm.
So Greater Delhi, I mean.
Yeah. And this also will include like taking account of natural drainage, and when construction occurs, doing it in a way that doesn't eliminate those, whether it's like
This-
Bangalore has lakes or Mumbai has mangroves.
Sure. And in this regard, I would also like to bring to the audience about the government of India, both the Jal Shakti mission, and we are working together with the National Institute of This. Looking at urban river, trying to prepare urban river plans, not difficult to do that for all cities, but just on the target 60. And Delhi is one. And we may also work on the disaster mitigation plan. So that is also, if it does happen, there may be some respite from the flooding the NCR is currently facing. So a related question coming to this top, that to project a 50% rise in rainfall driven mobility under a 0.5 meters sea level rise scenario, what low cost, high impact and efficient measures, as for example, localized pumping stations and each maintenance early warning systems, do you prioritize in resource?
Yes, I think the next steps should be to try to understand which of these is especially effective, cost effective, right? Informational interventions seem like early warning systems, they seem very promising based on other work in like the agricultural setting, the different from the urban setting, but given how low cost they are, they could go a long way. This may even include like informational campaigns to keep children away from public and things like that, since we're finding such huge impacts on children under 5. But at the same time, this kind of longer term sea level rise and its hazards is going to require not just like quick like turn them on quickly investments. It's likely to require foresight, planning. They tend to be kind of discrete. There's a whole class of things that are these kind of big discrete investments that we also need to think about. But yes, further work should look into the effectiveness. A lot of these things are already being done, right? Like pumping, things like that. Maintaining existing infrastructure is a big thing. Also, preventing exchange drainage, getting clogged with waste, that kind of thing. That could go a long way.
So I believe that the intermixing of water with waste, used water.
Yes.
So that's also one of the causes of, if not mortality, at least mobility
Mhm.
in many of the low-lying areas, low-income areas in most of our cities. We did a study with UNICEF a few years back. So coming to the last segment on the economic instruments, policy evaluation, and risk financing. I think given the steep rise in mortality and even modest increases in sea level, what does your analysis suggest about the marginal cost of delaying investments? As for example, drainage upgrades. Most of the cities we do not find that. We did a study for this city of Darjeeling Hill City, where to my surprise, I found that most of the infrastructure in terms of underground drainage, that they do not exist, or whatever minimal is there for the. So what do you suggest in that type of science, and could this be modeled as a type of adaptation abatement costs for?
That's a very intriguing idea as economists. Estimating these cost curves is kind of the holy grail of a lot of academic research, right? But at the same time, like I said, these are often lumpy investments. Like they're not necessarily continuous in nature. They require, and they require long time horizons also. Like, so if you want to reach a level of engineering or adaptation 20 years from now, you have to start that planning now, right? And some of the things that have been done in other places like Singapore or the Netherlands, they involve like creating freshwater lakes in places where there was salt water, allowing rainwater to be channelized there. These kind of things require a lot of advanced planning. So they have to really be put on the table right now if we are to realize their benefits 30 years from now.
Going to the final question, your paper treats localized rainfall as a quasi-random shock in our city. How can this econometric framework be extended to evaluate the causal impact of specific adaptive policies, say early warning systems, or maybe flood-proof housing upgrades for health or economic outreaches?
Yes, that's an excellent point in that we made a lot of progress, not just, I mean, not limited to this paper, but just the field generally on getting at the causal effect of weather extremes, whether rainfall or temperature. But there's been much less progress on getting at a causal effect of these protective measures that you just described, right? So we have we definitely get at the difference between slum and non-slum residents, but that's not, I mean, that part is not causally identified in the same way as an RCT, whereas the rainfall shock you in that way, right? So doing RCTs with these kind of measures or exploiting natural experiments of rollouts of these kind of things could get us the causal estimates of how to protect people as well, in a more rigorous way and in a way that illuminates mechanisms compared to what we did with just the non-slum and slum categories.
Thank you. I think it was a very good understanding of it for me. Your presentation brought a lot of light to the entire dynamics of both the rainfall and the types of facts, the climate. And before I conclude, I would like to open the floor for questions and comments. And if anyone has any question for the author, kindly introduce yourself and be very specific.
This is Mehboob Rahman from AIB. Thank you very much for this thought-provoking presentation and discussion. So I just wanted to, during discussion, most of the things about how to ask we are thinking, but can we have reflection from the global cities, different cities, which have confronted similar kind of problem like many Indian cities these days experience, like Delhi, Chennai, Bangalore, Mumbai. So in the last few weeks, there are several, we are experiencing the flood-like situation. So
Just yesterday, there was heavy rainfall.
exactly. So, and what they have adopted to overcome this kind of situation in short term and long term. So, probably that can be a good start by adopting the existing solution as well as localized solution or during discussion also. Highlighted. Thank you very much.
Do we take all the questions together and come back? Or how would we go about?
I mean, if there, we can take 2 questions at a time. Yeah.
Okay.
Shrikant.
Hello. Sir, this is Saurabh. I have done my master's from JNU. So thank you so much for such an insightful presentation. So sir, my question is basically related to the econometric methodology which you have discussed there. So like there is a lot of work on causal effect of these extreme event on mortality. So there is also one paper by Michael Greenstone. So there also they have discussed about these things. So sir, my question is ki how this particular methodology, like you discussed about RCT. So why RCT, or like most of the economists are using panel regression model also in this particular research. So my question is ki how these two are different, like which should be a better methodology for doing this type of research. So thank you.
Yes, starting with the first question, yeah, there are a lot of existing things that are done by governments in various cities. And if we can show which ones are really effective, that would go a long way. I mean, we need to focus not just on the problem, but also the solutions, many of which are already being done in various places, but we need to document that what they're accomplishing. And then the other question on panel data versus RCT. Yeah, so the advantage of I mean, RCT is widely viewed as the gold standard, as you must be familiar with, right, in rigorous identification of causal effects as opposed to correlations, right? The advantage of I mean, so with the weather, we're kind of in a lucky situation in that nature just puts it down for us. It's much easier to argue for its exogeneity than a lot of other things, right? And then using these panel data methods allows us to get like population level estimates. So RCTs can get very expensive if they get big, but here we're able to cover the whole population with observational data. So that's advantage of this methodology particular question. But at the same time, yeah, the adaptation measures, it would be good to have some RCT evidence on those.
Thanks. Ashwin, that was a very, it's me here. I'm Shrikant from the Center for Social Economic Progress and formerly was the Delhi School of Economics. So it's a very nice presentation, and Debolina's observations are very helpful. Just very quickly, just 4 points. Firstly, since you're doing rainfall, I was wondering if you had considered using anomalies, because you have the baseline. So it's, if you're thinking of a rainfall shock, would you not want to look at some sort of a deviation from the usual? So I was wondering if you had thought of or could think of using rainfall anomalies. That was one question. The second is, I think you're using death certificate data because you have the address and so on. So you did mention all-cause mortality, but the cause of death is usually reported. So I was wondering if there was something there that you could use, or what's the reason you haven't used it? You did mention there was some ambiguity about the cause of death, but I was wondering about that. And then the third thing was that when you're talking about infrastructural interventions, if the mechanism of excess mortality is through waterborne disease and, you know, vector-borne diseases, there are sort of fairly low-cost defensive behaviors like boiling the water or using ORS and those sorts of things.
The wash is
Yeah,
the acronym is used, right?
The wash, yeah. So yeah, I don't work in health, but yeah, you know, those sorts of things. And finally, from a public policy perspective, you know, Bombay loses about almost like 10 people every day to train accidents. And over a year, I mean, over a 10-20 year people, more than 70,000 people have just died in these. So I think you were mentioning a number of excess deaths as 1,000 or something from the rainfall per year.
Yeah, around 2,500 per year.
Well, I guess it's a fairly big number, but I was just from a
That's only happening I mean,
the rain is a monsoon season. But so what's really puzzling is the mechanism, since you said you haven't really got to that. But if it's, for example, if it's due to accidents, that may not happen at your residence. You know, you get electrocuted when you're going to work, or you fall into a manhole, and, you know, those sorts of anecdotal things that we hear about. So that's not connected to where you live. It may or may not be. So that's kind of another issue. So anyway, I think the one very important thing that I was thinking of, because I've been using climate anomalies, so rainfall shocks and temperature shocks.
Yeah, since this was 4 questions, can I just take this for the second one? Yeah, no, anomalies is the way to go. The way we're doing that is we have all these controls in the econometric model that are basically accounting for the regular variation. So we have controls for everything that happens on each week, so including the citywide average rainfall conditions. So the variation we're exploiting is, okay, one area got rained on, another didn't. And we're also accounting for each place's characteristics. So it's a comparison of a place to itself relative to another place on the same day that got different rainfall. So yeah, climate anomalies are the way to do this, and that's the standard. Yeah, you make the point about the going to work and getting affected by things. We have some sensitivity text in the paper increasing the scope of the area from pin code to wider resolutions, and we find relatively little effect of spillovers. It might be because the worst affected people are the under fives who aren't moving as much. What was your first question?
Defensive behavior, wash.
Yes, that could be very effective. It likely is. That should be one of the first things we look at in the future. And I think there was one more.
Cause of death.
Cause of death, yeah. So actually in the data set we have, that field is just not there. It's probably there somewhere in the records. It probably exists. We just don't have it. We would like to have it. The thing I was saying, yeah, that there could be like there's sort of the proximate cause of death, and there's something else which and the full detail isn't available, that variable, but nevertheless it would be very useful information.
Any further questions? Yeah. I can speak like this. No.
So I really like the fact that you brought out this slum.
Introduce yourself.
Yeah, I'm Depinder from NIUA on the climate team. So I like the fact that you brought out this difference between slum areas and the mortality, and also the life expectancy in these two areas. So these studies are also very good in highlighting what exists, and then on that you try to build up this model. So when you're trying to build up this model, have you also looked at, for example, see different other times in the year, temporal? Is there a spike in mortality, say in March to June, or in September to December? I mean, if there is none, then your methodology just says there is a monsoonal impact on the mortality rise. And yeah, if that is done, then that gives us a better understanding.
Yes, that's a great point. In longer versions of this presentation, I do, and it also in the paper, we show that the seasonality of deaths is such that they spike in the monsoon months, and they spike even more so for under 5 children. So that is consistent with these results, though that is just a correlation, right? So what we try to do is get at the causal effect here. But yeah, definitely the general idea of this shows up in just the seasonality.
Any further questions or comments?
So add on this mortality of the seasonal variability in terms of the rate and all, as you said, is there. But beside the mortality, if morbidity data is also being, that will give much more clear picture and add to relationship with the seasonal variation for the monsoon or winter, and then we have a direct correlation with the monsoon impact or rain disaster to morbidity and mortality.
Yes, morbidity is definitely important. I've read some statistic that half the world's hospital beds are filled with people with water-related diseases. So we should definitely look at morbidity in future work.
This is Madhu Tripathi. I have done my postgraduate diploma in conflict transformation and peace building from Lady Shri Ram College for Women. So in that course also, there was a concept of climate conflict, and it was also discussed related to the rainfall and rising seas into the urban cities. So I just wanted to ask, in your presentation, most of the things were covered, like mortality related to the rainfall and rising seas. I just wanted to see, is there any connection with also conflict related to resources crunches, and apart from that, migration conflict also, if it's and mortality related to that. So if you can discuss on that.
Yeah, the having better resources definitely seems to help in terms of the, and then there's also the, I mean, this creates shocks. One of my co-authors has done survey-based work on like, how does household income change if they're exposed to the flooding. So yeah, it also directly affects the resources and more so for the vulnerable groups.
Yeah, I think it's segregating slums and migratory population who come to the cities or work are basically living in slums. So there again the resource crunch is reflected. So let's cover that. So I would like to take this opportunity once again to thank you for your presentation and also the audience, the insightful questions and contributions. I think Indian cities are progressing in terms of their understanding of cities, means the city managers or the government policy part. If you look at the initiatives taken by the government of India in terms of the establishment of the climate smart cities center at NIUA, again the climate smart city assessment framework we have developed, where we are trying to understand the climate data from various cities. We started with 225 cities. And again, the government of India has launched, we all are aware of the smart cities mission, but again, an output of that is the cities 2.0, where we are trying to, under this framework, we are trying to establish climate data observatories for real-time data monitoring and of climate indicators. This would be done in 21 states across various cities, and the states of Assam and Andhra Pradesh, they have already approved their climate centers. And we are engaging with the remaining states to expedite the implementation. And also, I believe the econometric rigor analysis, granular urban data and local government connection which we have, I think that would really gives us immense opportunities for collaboration on joint research to develop causal models and that guide the investments, drainage upgrades, some slum upgradation, and also early warning systems, transforming evidence into equitable resilience strategies. And the key message that the key learnings for me, and as I believe as well as for the audience, that one, climate change is already causing substantial urban mortality. as well as morbidity, well beyond what official data or climate models typically capture. Again, vulnerability is not uniform, we all know, and climate risk, these magnify the existing qualities. Again, economic framing of climate health risk do drive more strategic, cost-effective investments. Granular, localized, causal evidence is a powerful tool for urban decision making. And finally, I believe there's an urgent need to integrate climate health evidence into planning and financing mechanisms. We at the Government of India level, we have initiated, but I think it's just the beginning. Lot needs to be done at various levels, the central level, the state level, the city level, and within the city also, I think the micro planning level, the wards, I think those need to really be empowered and they need to drive to take the climate action ahead.
It's a great summary of this conversation. It was great to discuss this with you and with all of the attendees here today. And I look forward to more collaborations in the future.
Thank you so much.